BIM software. So everyone is in, comfortable, and we can proceed. So first and foremost, I would like to introduce myself. I'm Shazwan Ehsan. I'm a BIM coordinator for PCSS. And today our topic will be OpenBridge. So, okay, what do we, what is OpenBridge and what can we learn from this webinar? So today's webinar is about just showing the efficiency of designing the bridge project using OpenBridge Designer and using a bridge information modeling approach using the products in the suite, which is the OpenBridge. This also can show the interoperability between the physical bridge model, OpenBridge modeler, and the analytical interface, and it can help you design and model your bridge projects faster. And it also has analysis capabilities in the RM bridge as well as new features. It also can produce project deliverables, which is the 2D drawings, the quantity report, geometry report from the bridge 3D model. So our speaker today is someone from Korea. His name is Eugene Lee. He is a senior application engineer for bridge and tunnel for Bentley Systems. He has been with Bentley Systems since 2012, and he has more than 14 years experience in roadway, rail, and bridge projects. He's also very highly experienced in the industry best practices and civil software implementation. Mr. Lee also provides consulting and training services to companies in the Asia Pacific region. Okay, so without further ado, I would like to pass the floor to Mr. Eugene. So, Mr. Eugene, on to you.
Okay. Hello everyone. My name is Eugene. I'm working for some bridge and tunnel product in Bentley Systems, and also I was bridge engineer already as you were. So I'm happy to sharing my knowledge with you. Maybe some OpenBridge designer will help you to reduce your a lot of some design consulting fee. Yeah, thank you. And then I'm going to show you my screen. Can you see my screen? Hello. Can you see my screen?
Yes.
Oh, okay, good. Again, hello everyone. Thanks for joining to this webinar. My name is Eugene, and then I'm supporting bridge and tunnel design tool for Asian Pacific region. And I'm excited to introduce the life cycle design for the bridge and using OpenBridge Designer. Already you have saw the sentence, the BIM is not CAD. That is meaning the 3D model is just part of bridge information. And we have been generating bridge information modeling and managing it. You will not be able to do entire of the task for bridge design by yourself. But the end user want to utilizing and managing and generating information model for the operating and maintenance. The challenge is how are you able to integrate generated information that created from each discipline? Also, you will face on like a problem when you integrate information model, manual data transformation, communication issue, and manual plan production. You must be working on connected design environment. And the design tool has to ready to set or get the information that created from several disciplines. An OpenBridge Designer is a specializing tool for the bridge engineers, and it is supporting the engineer to the bridge design from concept to reality model in concept design environment. It allows you can use physical bridge model and analytical design tool both. GINT is used to geotechnical information modeling. Generic component will supporting the bridge engineer to come over modeling limitation. And ProConcrete will be used to place the parametric lever into the model. And Luminarity will be used to simulate reality modeling to help the engineer understanding operating condition. And RM and OpenBridge will use to conduct bridge analysis and design. And physical modeling on OpenBridge Modeler will be based on load or rail alignment. Therefore, you must have load alignment to proceed the bridge modeling. Even if the load alignment is created by another company product, OBM can be imported using various file extension. Also, load alignment was created in OpenBridge Designer. This file can be used as a reference file to the bridge model and define the feature that will be engaged to line color and type and move to attach to attach the terrain model as a reference drawing. Once the alignment has been determined, the bridge type and bridge location should be determined, and go to Add Bridge to define the bridge name and type. In meantime, OpenBridge Modeler supporting deck with concrete and steel girder, RC slab, a CIP concrete box, and segment bridge, and assign the bridge name to the load alignment and specify bridge location through support line definition. And type desired number of support and select start and end point with bridge angle. And the support line can be copied in Excel and pasted to OpenBridge Modeler, and you can modify it anytime. Before explain how to place the segment, I want to let you know how to define balanced or unbalanced segment lengths using vertical bar on your keyboard. We will define pure segment lengths using colon because the analytical tool RM has to know middle of support point. The next step is I'm going to place the bridge segment and move the place segment to insert the bridge segment on the load alignment and set picture that predefined to DGN library and select the template that also define the variable for this bridge. And define each number of segment and segment lengths. Peer segment, already you know, peer segment represent to some header segment on the peer. And place the segment to support line. And OpenBridge Modeler give us this warning message because we define the segment lengths are longer than available spacing. So modify the proper segment lengths and place the remaining segment. And move to close button to create key segment. And specify minimum segment length. Then OpenBridge Modeler is looking for less than spacing and will generate the key segment. We are done. Place the bridge segment. but you want to define some variable along the bridge axis. For example, then you want to define the bridge height. So I move to constraint, then select variable name to specify the constraint. Also, this variable value can copy it in Excel to OpenBridge modeler. And you are able to verify the variable through the table and graph. Then OpenBridge modeler will apply to the model, and then the model is updated. Bridge engineer also wanted to know each segment maximum length and weight to specify pump traveler capacity. You can verify it through report button on OpenBridge modeler. OpenBridge modeler updated to generate a variable column and footing using custom 2D template. The first step is you have to create a column and footing template with a constraint and variable for this pier height variable. And it will help you to create custom substructure more easily. So move to a variable column on the multi-column, and then you can see two pier with the variable column by default. And I added pylon using updated function, select column, and change the column type to variable, and select the variation to specify column template and variable. And you can define column variation using predefined variable and constraint. And select the stroke to place the cross girder. You can control specify cross girder size and location. And you can define isolate, drill shaft, and combine the footing with or without fire and custom footing also. Also, you can specify circle, circular, and H shape profile, and then you can define pile layout independently. Sometimes there is a special structure that needed to be modeled, architectural fear or custom apartment. Those elements need to be modeled using hand draft tool with a left or non-existing parameterization. Therefore, any change in structure force on almost the total redraw of the structure. After modeling those custom structure, engineer need to design, detail, and quantitate those elements. The use of a traditional tool in modeling force, the engineer to remodel the structure in his analytical solution and do a manual calculation of the quantity. There is also a problem. The most engineer not familiar with 3D model environment yet. However, the engineer and designer should respond quickly and flexible to design change. To do this, it is necessary to reflect in advance the scenario that can be changed to modeling using variable and constraint. And I'm going to show you some user case. It could be difficult to develop using typical design tool by all requirement of bridge engineer. This is one of the reasons why I would like to give you this presentation to help you for the bridge design using OpenBridge modeler. This apartment created for Texas in USA. The most difficult challenge was to apply variable shape of corner block to a model. The corner block shape had to be changed by condition where bridge square angle was 0, more than 0 to 15 below, 15 to 25 below, 25 to 45 below, and more than 45 degree. Also, negative skew angle had to be applicable. Then the next step is I'm going to explain how to place the substructure. There are two elevation definition methods on OpenBridge modeler. And you can define the elevation that is based on horizontal load alignment, while DTM that is laid with the terrain model. And we have to activate the terrain model before place the substructure. Then putting top elevation will define depth based on the terrain model. And move to place the abutment and select profile feature and template. And check the desired options. And select the support line to place the abutment. The templates are based on parametric models, so the modeling backward height and width will be adjusted automatically due to the option, even though the template real size doesn't refer to this bridge model. And then I'm going to place end of abutment. People say we use the method. And I'm going to place the pier to this model as same before method and move to place the pier and select proper feature. I'm already preempted you. The feature will engage to line color and types. And select a proper pier template and desire the support line to place the piers. And specify putting top elevation that will be based on digital terrain model. And OpenBridge modeler can place three types of bridge bearing, like some cube and cylinder and cell. And I'm going to place the bearing using cell type and select a cell template and define the center of bearing and horizontal location from center of load alignment and specify bearing seat dimension and select support line to place the bearing using predefined information. Then abutment bearing seat elevation will adjusted automatically from the vertical load alignment elevation. And I'm going to place the other bearing using the same as before method. During you have designing the bridge, you will be able to have a new load alignment from load or rail designer. The pain point is we need to recreate the physical modeling, but OpenBridge modeler doesn't need to do it. Because OpenBridge modeler allow you can change the bridge geometry automatically through the alignment function and move to attach to attach new load alignment as a reference drawing. And you are able to confirm fully change the alignment, horizontal and vertical. And move to alignment and select new load element for moving the bridge modeling from old alignment. Then all geometry of bridge will be changed automatically, bridge plan and elevation also. I'm done creating the physical model, but we have to verify the elevation of footing top because the real terrain model will not flat. So move to open profile model on civil tab and open profile for the vertical alignment. And select 3D curve button to producing 2D drawing that be based on 3D model. And then change the exaggerate scale. And I'm going to change the top of footing elevation. And select the update 3D cut. Then the drawing will be updated that be based on this 3D model. And this step is I'm going to explain how to define super elevation using reference drawing that was generated from OpenLoad Designer. And specify left and right boundary and select a start station and step spacing to produce 2D cut drawing. And verify the 2D cut drawing, you can confirm that the superstructure didn't define any segment. And move to attach to attach the super elevation drawing as a reference. And assign the super elevation using the assign button. And select the super elevation object and segment group to apply super elevation. Then also you can verify the data. We need a post tab to assign the super elevation because my bridge segmenter were grouped in four groups. And you can define the super elevation through the constraint before you watch the slide. Then you can verify the super elevation that was applied by super elevation. I completely tandem point defined using constraint and variable, and I'm going to verify it through section variable and move the verify button and modify the super elevation and each variable laid with these sections. Then you can see the adjusted tandem point by these variables. When you start RM Bridge with a standalone in OpenBridge Designer, OpenBridge allow you can accelerate design speed through the bridge wizard. You can define all information related with bridge analysis and design, and it will generate analysis report automatically. And you enable to modify or update the bridge model anytime. Also, you can see several partial results like a cable arrangement, rail and structure interaction modeling, wind dynamic analysis in OpenBridge, and it will help you to create a model more easily. You can customize the calculation report using RMView. You enable to use your custom company logo, can select input data and customize the result diagram, and you can generate the report as a very output format. Finally, your full report will be updated just one click. I'm going to send the physical bridge model to run analysis, and you can select design standard and material group. And OpenBridge modeler allow you can select the option to create the finite element of footing and file. And I'm going to modify spring constant for bridge bearing. X represent vertical and Z is for the orthogonal to the bridge axis at the abutment. And I'm going to set up fixed support for bridge bearing in both the piers. Also, you can define file spring constant if you didn't check file transfer option. You can see the spring zero for spring constant to connect footing and the ground. And confirm the desired material name for each component, and you send it OpenBridge, then the analytical modeling automatically generated. And you can see finite elements in OpenBridge that be based on physical bridge model. And move to modeler to verify the each tandem point name. This point is text from OpenBridge modeler. And select the main girder to verify the boundary condition for this bridge bearing. Basically, OpenBridge will create triangular shape boundary condition for the abutment simulate accurately bridge behavior. And you can see the green element for the bridge bearing and connecting ground, and yellow element represent rigid connection. And initialize create the analytical data and recalculate to check element, node number, and structure system. And you can see tandem numbers and segment elements. And it is important to preparing tandem checking plan. This plan should have a group name and number for tendons. For example, LVL indicate left bottom tendon and left span, and the arrow represents jacking direction. And I'm going to explain how to define the tendon profile and stretching action for the top and bottom tendon. I'm going to specify the tendon profile on the PO1 only because the other tendon definition will be similar with this method. I move to cantilever wizard to specify tendon profile and stretching action for each construction stage and create a tendon group and select tendon material name and specify start to offset for tendon numbers and define tendon ductal area and specify constant to calculate the tendon stress loss. And activate segment on the PO1 and select pointer name to each segment using Control key and mouse left click. And define stretching action, and then you can see created the tendon. And copy this tendon to create a new one. Then select pointer name to delete line. And copy previous tendon and delete line and repeat it until tendon number 1107. And modify stress label to apply tendon stressing order. You can see the descending order for tendon stressing and modify the stressing action that be based on tendon stressing plan. And copy this group to create a TRO and modify tendon start offset. And replace the pointer name to TRO from TLO. And complete tendon definition on PL1 using same as before method. But you need to modify the start offset and replace pointer names. Imported actual construction stage was 17 from the physical bridge model, but OpenBridge allow you can reduce the construction stage through time stop function. Time stop delay the start of cliff and shrinkage on specified element. Also, it will help you reduce manual work before you don't need to specify all of construction steps. I'd like to explain the mark photo from a traveler in the schedule before defined construction stage. Plus, I mean the traveler is put on the segment. Asterisk mean the traveler is moved. Hyphen mean the traveler is taken off from the bridge, and blank mean no movement of the traveler. And I will specify the element for the substructure segment on the pier and boundary. Also, it will not give you all of construction schedule definition in this section. I'm going to explain how to specify the construction stage 1 to 7 only. Move to schedule in cantilever to define construction stage and create a new group for this bridge and enter traveler weight gamma for wet concrete and ECC1 is ECC1 is form start of the segment to prompt the anchor point of the traveler. ECC2 is spacing between front and rear anchor point. ECC3 is horizontal eccentric offset from the bridge axis. And set up the prefix and starting stage number for the construction stage. And activate the element led with construction stage, segments, column, footing, and boundary elements. And specify stage for the segment on Pier 1. And also define the segment on Pier 2 in the same stage. And define the aging period for the substructure and specify boundary element enter A in the stage 1. And then I missed the column peer to columns, so just activate column to peer to column element. And you are able to verify the rigid link is not defined. The rigid link between segment and top of the pier didn't define it. So I just typed to A, define the boundary element. And you can verify the activated element in each construction stage. And select Recalculate Analyze to conduct analysis. And check calculation option, enter summation load case name. And move to plot, and you can see the plot for the camber result in each construction stage. And you can verify the result to create the Excel files. And OpenBridge will generate the XML file for lever and tandem profile that be based on structural analysis result, and close the RM and select updated button and select the XML file in OpenBridge Modeler. Then actual tandem profile will be updated. And you can see the tendon geometries and then tendon stressing action also. Plexis is for the geotechnical analytical tool inventory, and it allows you import, create the 3D model as a DXF format, and adjust the variable to modify the PL geometry, and it will export to DX format. And the next step is import the PL geometry to Plexis. And inactivate the subsurface and base point, and specify top offset to place the pier into the soil model. The next step, apply design load and boundary condition and execute the analysis, and then you can see the displacement diagram and pile pose and movement due to design load and soil condition. And you can see how to place the parametric lever in OpenBridge Modeler and switch the workflow to Pro Concrete and place the lever in column and putting through the GUI. You enable to place the lever using the window box. Also, it allows you to define the number of levers, left splice, and end shape also. And change to OpenBridge Modeler and change the load alignment. And then bridge and lever modeling will update it to be based on the bridge alignment. And also you can place the parametric custom lever to custom element using the functional component. I generated some guideline for the lever shape using functional components, and the guideline be connected with custom solid using constraint and dimension. Those lever geometry be adjusted that be based on custom solid dimensioner. Also, you enable to control lever size and spacing anytime. In this slide, I'm going to explain how to generate the bridge report. OpenBridge allows you can generate the bridge geometry report for survey and quantity report, including concrete volume for each segment and component, bearing, and tendon also. And can check the quantity in a chart. And it can make the report several file extension without any data loss. For example, I'm going to generate this report as an Excel sheet. Just define the file name and file path. Then you can see generated report that are same format and chart. And the bridge engineer have to create a real coordinated report for construction survey, but it is not easy to generate it at required time. We will be able to create the report anytime for geometry report. Just select desired geometry and define the boundary to generate the report and set up the location and format to present the report. You are able to see the result and verify each location for the report. OpenBridge allows you enable to produce 2D drawing using several ways. Dynamic view is the one to create 2D section drawing for selected station. And select desired station and set up the drawing style, then drawing extracted from 3D model. And go to setting button to set up the substructure drawing format and style. And select the substructure to generate 2D drawing. And you can see the apartment drawing, plan, section, and pile layout. Those drawing are 2D drawing produced by OpenBridge model for the pilot project in LADOT. You can see the bridge plan via general view and Riva detailing drawing. And I usually like to show you more elaborate drawing generated by each engineering company, but please understand that I cannot show you it for some security reason. And you can create the bridge model using bridge wizard, and it will help you reduce your design time. I'm going to attach two reference files for the alignment and terrain model, but you don't need to have the alignment. Then OpenBridge modeler will create new straight alignment. And select bridge wizard to generate the bridge model and give the bridge name and specify bridge type and select the template for support and substructure. And you can select the alignment and starting station to place the bridge model. And also you can specify the component material name and type and press OK, and then it'll take less than 1 minute to generate your bridge model through the wizard. After then, you can move and change the alignment for this bridge model. The model reader component should consolidate into the parent model file. The component will be crashed due to miscommunication and manual data transfer. And you could find out the config to 3D model by manually. But it will be harder to find out the conflict detection to the consolidated model. OpenBridge modeler allow you can check the crash detect automatically. But you need to define crash detection rule. You can also make the rule using attached reference file and define the clearance. Then you can see crashed component visually. And you can see the help resource to help you learning OpenBridge Designer more easily. You will be able to access recorded video through the hyperlink in help resource. Also, you can get the help anytime from Bentley Technical Expert. And also, we are operating the YouTube link for OpenBridge and OpenTunnel. And you can use Synchro for the simulation, not only construction stage, but also safety detection. You can create the bridge component without any data loss to simulate the construction stage. I'm going to take the bridge model and the template structure to the Synchro and import the divided project for the bridge and temporary structure for construction simulation to
I'm
Synchro.
sorry, Mr. Eugene. I stop you for a while. Mr. Fahmi, I think you are presenting inside the webinar. Could you turn off your presentation?
Eugene, yeah, showing the screen of form, I think. Yeah.
Mr. Fahmi, I think
So
I don't know whose screen is this.
No, it's not mine.
Oh,
My screen.
oh no. It's mistake. But yeah, someone's presenting a different screen.
Oh,
Yeah. Okay. So it's back. Okay, thank you.
okay, you can use Synchro for the simulation, not only construction stage, but also safety detection. You can create the bridge component without any data loss to simulate the construction stage. I'm going to take the bridge model and temporary structure to the Synchro. I import the divided project for bridge and temporary structure for construction simulation. And you need to specify to active component and construction schedule for this simulation. And you can simulate that be based on construction schedule, and you can verify the quantity for each construction stage on a chart on the top right. And also you need some reality simulation when you complete the bridge model to predict how this model affect to the real site. Also, you can simulate the traffic flow using big sim data. In additionally, I spent 2 days to generate the whole of bridge model using OpenBridge Designer. And already we understood that I will be rare to design the bridge as a product of one company. And Bentley has been utilizing IFC to make the connected and open-ended design environment. BIM is not CAD. BIM is a deal with process, data, and change management. And Bentley has been developing and enhancing to build the design environment through IFC. You can generate IFC using the two methods. I'm going to export the bridge model to IFC in OpenBridge Modeler and select generate bridge model to export IFC and enter ProConcrete export IFC command to key in, specify direct to save the model, and then IFC file will export. And you can see the way how can I export IFC through the connection center. And go to related project and select iModel to open the file. And you can see modeling history led with this model. And select desired model version. And select export to IFC. Then verify the contents and export it. And move to Bentley Cloud Service to open exported IFC file. And download it to local computer to verify and attribute in Building Smart. And then you will investigate the bridge to capture the surface of bridge using drone. You will also able to control the drone remotely and capture data will convert to the electrical information and consolidate with the existing physical bridge model, and it will be used to the maintenance. And the converted data will be used to machine learning for the crack and corrosion. And you can see use AI for the crack and corrosion detection. And you will use iModel for the inspection monitoring. You can activate desired component to verify the inspection status through the chart. Also, you enable to develop custom UI using iModel and Power BI. And this is a user case for the bridge health monitoring. They build a physical bridge model to address the structural health status. And this user developed Forum RM using OpenBridge for the bridge performance assessment. Okay, I'm going to open the Q&A session.
Okay, thank you very much, Mr. Eugene, for the informative presentation. So we open the floor for our Q&A. Okay, so I see there's some questions here in the chat from Mr. Ahmad Faris. I would like to know the effect on the bridge load design. Is there any effect on the load of the bridge if we attach any utilities such as water pipe on the bridge side? The water pipe is considered as live load or dead load. So, Mr. Eugene?
I'm thinking it's depend on the your desired requirement your environmental requirement, because if we just focus on the bridge engineer, maybe the pipe is just seems like a dead load. But if you move to maybe some ENI piping stress engineer focusing on to some water, maybe there will be some live loading. But there maybe in bridge engineer would be some considering some some dead load on the bridge, because how can you specify some loading factor? There is no any some guideline for this one.
I see. Thank you very much for the answer. And we have another question here from Abang Irwan. The bridge design include the load or provide trench or platform for utilities such as water pipes, telcos, or street lighting.
Yeah, if this asking focusing on to some physical bridge component, physical bridge model, and then you enable to generate some like this component using some parametric cell or some static cell, graphic cell, and then you enable to place it to OpenBridge modeler.
I see, I see. That's very informative. Okay, so I also have a question on my own as a BIM coordinator. What is the interoperability between the OpenBridge software with other BIM infra softwares, such as maybe such as Civil 3D? Any interoperability between them?
Yeah, so OpenBridge modeler is based on some load or alignment. The meaning is we need to have some load alignment, even though the load alignment is generated by some the other Bentley tool, some like a Civil 3D. And then I'm thinking is a Civil 3D enable to export some IFC format. And then OpenBridge modeler are enable to import the IFC file, and then we are utilizing that alignment.
I see, I see. So we have a question from technologist Tiong Mei Kue. In Malaysia, were the bridges take seismic load into design consideration?
Maybe some this bridge object is to deliver some water, and maybe water will be some major load for this bridge. And then maybe you enable to calculate some equivalence sediment loading, but due to some water slushing by sediment loading, and then you are consolidate the behavior between water and structure system. The structural analysis method is similar with some water tank.
I see, I see. So, any other questions from the participants regarding open bridges? Yeah, I think what technologies Tiong was mentioning is regarding the seismic load as in earthquakes.
Yeah, I'm only told you some earthquake. There is some a lot of earthquake methods, some like equivalent static analysis, or some response spectrum, or time history analysis. But I'm thinking is maybe this bridge will be issue between water and structural interaction analysis. And then maybe you enable to create some water behavior. You enable to create some two type of effect by some RM bridge. First one is a time history, or the other one is equivalent to seismic loading due to water slushing and the other effect.
I see. So does that satisfy your curiosity, technologist Tiong? Okay, so we have a question from Fakamizi here. In brief, could you explain how the load case for is the load case for drawbridge design?
I'm not sure I'm not sure he's some question correctly, because as you know, there are a lot of loading type for some bridge design. And then I'm thinking you already have using some stat or some MIDA CB or SEP 2000s. And also RM bridge have a lot of loading type for the more elaborated for construction stage analysis. And also I'm thinking or RM bridge already have the other loading type if you compare with some common structure analysis tool. And then you can see you desire the loading type. And then just please let us know if you need some particular loading case, if you couldn't see the loading type on the other some FEM solution, some like a SEP or MIDAS. And then I'm going to raising photo enhancement to our development team.
Okay. We have another question here. I heard from recent MRC seminar in KL that the new bridge design guideline needs to account seismic loading based on
Shazwan.
EN.
Yeah, Shazwan, that's my clarification to
Oh, okay.
yeah, make quiz.
Oh, yeah, I'm
question.
sorry.
Yes.
That is a
Yeah.
question.
No, it's just
Yeah, I
like
think
additional
I
clarification.
thought you were seeking more clarification.
Yeah.
Yeah. Okay.
Please.
So, any other questions from the floor? Okay. So, talking about Bentley softwares, I saw that the 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 RM software has allocation for 4D design, 4D running. So, how does it differ from Synchro?
Synchro is, as you know, some RM bridge is some analytical tool, not physical bridge model. And but also you enable, even though you enable to simulate the construction stage, and also that's why I just show you some like this video. And then this video is the modeling, the temporary and some major bridge model is created by some OpenBridge modeler. And then I just import the model to Synchro here. After that, you can see combined the bridge model with the temporary and major bridge here. After that, you just assign the construction stage for the simulating, and then maybe some specify the equipment behavior. After that, you enable to see the quarterly report each construction stage here. The meaning is I'm thinking is a I'm thinking it's a synchro. There is no any some streamline with some 3D software because synchro enable to import the CAD format and also enable to import the DGM format also.
Yeah, maybe I will just add on, if you may allow me, Shazwan.
Yeah,
So
sure.
just to put it simply, OpenBridge is for engineers to create the bridge design as well as a 3D model, and Synchro is for what they call that, the project management team to link the components of the 3D model of the bridge with your work program. Just to put it simply.
I see. Thank you for your answer.
Yes.
Okay, so any other questions from the floor? If there is no other questions, we can move over to the certificate ceremony. So I would like to present this certificate of appreciation to Mr. Eugene Lee for his contribution in this webinar and for this very informative presentation of OpenBridge. And I hope this really helps all those consultants out there who are looking for easier way or faster way to create a bridge model or to do design analysis. So it seems that this software is the way to go in this digital age. And before this, I think I would like to pass the floor to my colleague Bell on for some promotion here.
Okay, thank you very much, TS Shazwan. Mr. Abang Irwan, later we can go back to the ScanB page for your attendance. Don't worry about that. But let me just introduce PCSS. So PCSS has over 50 years of collective experience in project management and understand that just as projects are unique undertakings, project management methods for each organization can be different depending on individuals' needs and requirements. So our philosophy is to improve the process of delivering and operating the built environment. In general, terms that will translate into making the delivery, operation, and renewal of our built environment safer, more efficient, and more collaborative. So, who are we? We are PCSS are gold partners with Bentley and also Oracle, and we are registered under Project Management Institute as well as the HRD Corporation, and we are the official training provider, registered training provider, and we provide services like consultations, trainings, and also software. Next, I would like to talk about our upcoming workshop. PCSS will be hosting an upcoming workshop titled Open Road Designer, an introductory hands-on upskilling workshop for MX Road users. It is a one-day workshop that will be conducted at PCSS Training Center here in Cannon Square of Jalan Stutong Baru, Kuching, Sarawak, and the class will be taught by industry experts in the region. So available dates for this upcoming workshop will be on the 15th, 16th, and 17th November. So individuals that are interested in joining this workshop can scan the QR code on the screen or click the link in the chat box that I will be giving later. So this workshop aims to aims to users to understand the concept behind how the software works so users can be confident in using the software regardless of the design challenge they face. Okay, next. PCSS is delighted to announce to those who have participated in this OpenBridge webinar, you are eligible for special year-end deals. We will be giving rebates on our Primavera PSIC Basic, Resource or Advanced courses, as well as Synchro Basic and Advanced training. We will also be giving rebates on software when you purchase either Synchro or Primavera software. The special offer is valid up until March 2023. So you might be asking, how does one become eligible? Individuals must provide proof of attendance certificate to be eligible for this special deal. Please do fill in the survey form provided at the end of this webinar to register your entitlement for this privilege. So to know more on our other trainings and software, do scan the QR code available or visit us at our website at pcss.com.my. And to keep updated on all our latest updates, do follow us, like, share, and subscribe to all our social media platforms as stated below. And you will be updated on all the latest updates. That's all from me. Thank you. And I will pass the floor back to TS Shazman.
Thank you very much, Ms. Bell. So we can proceed to our photo session. So everyone can turn on their cameras for our photo session. One. Okay, so we on three. 1, 2, 3. Smile. Okay, so one more. 1, 2, 3. Freestyle. Okay, that's all for us for our webinar series for Open Roads. Thank you everyone for coming to this webinar. I hope you have learned a lot in this OpenBridge software, and hope you all have a very good day, great day, and stay safe. Thank you.
Okay, thank you. Bye-bye.
Thank you. Bye.
Thank you. Bye.